Bienvenidos. Hi, everyone, and welcome to the next session of On Data and Design. My name is Darian, and I'm your tonight's host. Actually, it's still day, but it's tonight. So we will have today three great speakers. It's Martin, Christian, and of course, Nicole. Three great talks about visual systems. And the rule behind On Data and Design, if you have not been part of it before, we have online talks. They will have a total length of 60 minutes. It's going to be here in YouTube. You can ask questions. There is a link below the video. You can ask the questions on Slido. You can also upvote questions if you think they're interesting. And each of the speakers will have 20 minutes to talk about the topic. And then in the end, we will collect the questions and answer them. So it will be tonight in English only. Already telling the big news that tonight, if somebody is in Basel, we will meet in 2 hours in a bar to have a drink. Martin and Christian will not be part of it because they're not in Basel next time. And yeah, so basically that's the whole concept. And I won't introduce the speakers. They will introduce themselves. And we just discussed before who will be our first speaker. And the dice fell on Martin. So Martin, the stage is yours.
Thanks a lot for the introduction and the invitation. My name is Martin Lorenz. I'm going to share my screen and show you my presentation. Please leave questions. I was asked to be very fast with my presentation, 20 minutes. And I had obviously, like always, too many slides. Let's start. Okay, 2points.net. That's the studio that I founded together with Lupi. Lupi and me, we are not alone. We have we are with Elio on the bottom right in Barcelona. So we are based in Hamburg, Germany, and Barcelona, Spain. This is our happy place. So 2points.net from the start was always in between the pillars of learning, teaching, and applying. Right now, we are very much interested in coding, software, motion design, augmented reality, artificial intelligence. And we teach regularly since 2006. We taught until 2 weeks ago at the KBK in The Hague, and still in Barcelona as well at the Elisaba. And then everything that we learned as well through teaching, we apply at 2 points. And we are building a website, which should be like a quite complete, or should become quite a complete archive of flexible visual systems. Okay, I was asked today to talk about flexible visual systems, the book. But before I start to show images of the book, I want to give you a little bit background where these ideas are coming from. So I graduated from the Royal Academy of Art of The Hague in the 2000s. And if you lived through the 2000s, then you probably were aware as well that something happened, something changed during that time. And it was this time where we saw popping up a lot of different terms that try to describe a new, different kind of identity. Before it all has been designing logos and then a couple of assets. And then they were applied to different deliverables. And then new terms started to pop up: generative identities, dynamic identities, liquid identities, fluid identities, evolving identities, living identities. They had different background stories, like generative identities. They were inspired by generative art, liquid identities by the theory of Zygmunt Bauman of the liquid society. But it wasn't really clear if they're really different types of identities. So me, as a recently graduated student, or not student anymore, but beginner, I was very confused during that time. But it was clear that something happened. It was going from logo to system design, because the system was able to do more things. The logo basically is just one symbol, it's one message, but the system is a language that is able to express many different messages. So we had this paradigm shift from symbol to language, if we look at the function of a visual identity or the tools of it. And we had to change from static to flexible, because more and more the websites were important, the devices on which we were looking at the different identities became more important. So we had this change from static to flexible. This confusion, but also my interest in systems, led me to move from North Europe to South Europe to Barcelona, and start a first master and then PhD in design research. And I wanted to research the questions: how do flexible visual systems work? It seemed always like very intuitive how they develop the different identities, and I wanted to know if there are like different types and functionalities. So before I started to make case studies of recent visual identities, I started to analyze bibliographical sources, and these are the diagrams that I made from authors like Wusius Wong, but as well Bertin, a cartographer, French cartographer. Different authors, mostly from the 70s. They were designing in a different time, so it didn't really work for me. But I tried to take what I could get from them, and it was comparing functionalities and terminology. And then I started to make case studies and use this analytical model as well to analyze recent new visual identities. And it became so complex that my tutor told me that this is not how an analytical model should work, that this actually doesn't help anyone. This doesn't make sense. This is just a one-to-one map of reality. This is too complex, and a model should simplify to be able to express something. So I simplified the models that I made to something very simple. And this is the model. There are systems that are based on form and systems that are based on transformation. I'm going to explain now what this actually means. So a system based on form, as you can imagine, works with different kinds of shapes. And in their combination and permutation, you get different constellations and different images. So an example would be from the design studio Uncommon, the Coventry City project from 2020. And you see here a very simple grid and a couple of rules, like which colors to use, how small you can divide the modules, what kind of elements do you use. And now motion has become as well part of the visual identity design. So the rules for the motion design are an integral part as well of the visual system, which 20 years ago wasn't the case. And now we come to a very interesting, the second type of system, which is very interesting to me. And just like an anecdote, I made this book actually for graphic designers that do visual identities. But what was really interesting to see is that actually a lot of people from creative coding bought this book, and they really could relate to the content of the book, which was really interesting to me, because obviously, I mean, I see the connection and everything is logical and could be coded, but I'm not a very good coder myself. So I was surprised. About the system based on transformation, while the system based on form works with actual objects, the system based on transformation designs a process that generates different kinds of images. And the source of the image is actually not that important anymore. Here I took typography and I just put it on a scanner, and then I moved the typography on the scanner. So it deformed in this way. But you could imagine that if I take a photography or if I take anything, an object, after a while, you would see the common thread in between the different images, and you would recognize the language of the scanner, and the stuff that you're scanning is not that important anymore for the recognition. It's going to be the process, how you generate these images. As an example for this kind of system, this is for OVG from Rejane Dal Bello when she was still working at Studio Dumba. And you see here that taking something static like this logo and then throwing it or projecting it over an object. This is digitally made, but distorting it in that way allows you to generate different kinds of images. Yeah, and then the big frustration or disappointment. I worked on this dissertation, on this PhD for 10 years. I mean, if I'm honest, I wasn't just doing the PhD. I also had in between 2 kids, and I wanted to see them, be there for them. Then we had the studio with Lupi, but it took me 10 years. And then I think like maybe 10 people read my PhD. So I thought I have to make something a little bit more practical, something that everybody can use. And I made this book, which is out since last autumn. And there's an introduction where I talk about different subjects that are important when you work in visual identity design, but in general as well about how you organize design teams, different articles. And then there's one chapter 1, about flexible visual systems based on form. And it's structured like this. So you have, I always start with a basic element, and then I cut it in a couple of parts, so it's easier to combine with other elements. I make a component out of it by having a couple of rules, like mirroring it or rotating it. And then I do stuff with it, like lines, frames, patterns, or labels. And I put typography on it to make out of this component a symbol, like a logo, a profile, picture, or whatever it is, or just tools for designing, like assets. I even show some typographic solutions, so how you could, with the same kind of element, you see here that I'm just working with a quarter circle. I can make typography, I can make lettering out of this, and actually very quickly as well change the style of the letter by just changing the basic components. And then there always has to be a rule how to apply these elements. So you could stretch it, or you just could repeat it. And then there's a second chapter about transformation. And there I'm just describing different processes, what you could do with either graphic elements or with typography or with images, like rotating them, or repeating them, just like different processes. And to make this, I mean, this should just like exemplify different methods, how you could work. And to make this a little bit more concrete, I show you an example of 2 points where we used a similar approach. So this is an exhibition in Barcelona, Blacklight it's called, and it was showcasing psychedelic art from the 50s. And so we took it quite literal. So we made a representation of a light, which is like going from white to black. Then we invert this because the exhibition is called Blacklight. Because the images that they're shown us, the curators, there were, a lot of them were looking very much like op art, line art things. We turned this into lines. And then we just cut them in quarter circles. So we are able to create new things out of it. A circle is quite a closed form, and it's difficult to combine or make new things out of it. Just like by cutting it in 4 pieces, there are more options of combining in different ways. Then we got our good friend Tim Rodenbröcker to design us a tool or to code us a tool in processing, but later as well in P5.js. So as a web-based tool as well, the potential future audience of the exhibition could make their own designs. And we made a competition out of it. People could upload their designs to their social media profiles and then could win something like a bag or something. But we also made a font out of it. So here, the things that you see here, all the letters that you see here, they're all built with the same components. And it's just a quarter circle and a straight line to connect a couple of letters. And because this is a very simple setup, it's also super easy to make a variable font out of it. So this is just the 2 masters interpolating in between each other. And now I'm going to show you a couple of images of the project. So you see here that we applied this quarter circle then and made a pattern out of it. We made lines out of it. We made these forms out of it. And to limit our options or to have already a system for the way how we design the deliverables is very helpful, especially for small studios like us. Like this, it's a huge project in whole Barcelona. There, everywhere will be your design if you design for a museum in Barcelona. So in order to be able to manage this with just 3 persons is having clear rules how to design. And this is what a system actually makes possible. Wayfinding system, banners in the street, the whole street is filled with these banners. 3 minutes. Okay, I'm rushing now to, okay. So this is then the last project that I'm going to show. What's important to understand, and this is the trick of the book as well, is that you could look at the book and you could think, okay, I could do the identity that I want to do exactly like this. But the idea of the book is that functionalities keep the same in many projects if you look at the projects, but the aesthetics can change a lot. So I'm taking here now as the last project to show you Center for Complexity, which has the exact same setup. So it's also quarter circles, but the aesthetics are changing a lot. So just to give you half-second explanation what this is. Center for Complexity is a lab of Rhode Island School of Design, a research lab. And it's super interesting what they're doing. They're researching real project and it's like real life activism as well, using design thinking and system thinking. So every project of them that they research is very different. So we wanted as well for them just to have a container which they can fill with very different forms. So for every project, they can have a different font. And you see here that we fill this container with very different fonts. And as these are also components, we can generate very quickly lots of different kinds of fonts. And this is then how we applied this. Templates for moving posters, also very easy to change because it's just a font. Posters. And that's it. I don't know, 20 minutes? Did I get it? Okay. Yay.
You did. Excellent. Excellent work. Thank you, Martin. Super nice. So I see already there are 4 questions to Martin.
Yes.
I just want to motivate people to ask more questions for afterwards, so that we have a nice stack of questions to answer. So the link is, once again, it's below. You can also upvote questions if they're interesting. So please participate in this virtual experience. And yes, and now after Nicole, I am really, really happy to have Nicole to explain the book we have been working on. Nicole, now it's you, your turn. Unmute, mute, mute. Advertisement break. So, yeah, we have actually a lot of viewers. I'm happy to see that. Okay, Nico, are you ready?
Okay, so I made it.
Yay!
Yeah, so hello. I think it's the first time that we are doing our own like talk on data and design. You can see here it's our team from Superdot. We are a small studio with just 4 people. So the second from the left is Diane, who is the moderator, and we have Aaron, Sarah, and me. And this is us during the pandemic working on the book. So that's why we were wearing masks. The thing is, we are quite interdisciplinary team from graphic designers, developers, and business informatics background, which fits quite well for data visualizations. Does not move, the slides don't move.
Okay, don't worry. The excitement is rising. Perfect.
Okay, good. So this is a part of our work we were doing in the studio, like in the last 10 years. We are working for organizations, institutions, but also bigger corporate companies like the Swiss Post, institutions like the UNICEF, Swiss National Fonds, and so on. So really a broad field. We are doing print design and also web. So we don't make a difference in that. But the latest, and I think probably also the biggest project, is our book, Visualizing Complexity, Modular Information Design Handbook. So the idea of this book was to make data visualizations more accessible from the data science side, more for the designers maybe, but from the design side also for data scientists. And the idea of the book is to show a method that we developed to make more innovative diagram types. We were working with this method in the studio before. We are also teaching. So this is a way to summarize it and to make it accessible for everyone who is working with data somehow. Actually, I have to tell that this book is not about rules. There's no like wrong or right. The idea is that you try, and the system is also not based on a specific tool. So it's not dependent from a specific software or from a design tool. It's more like a general approach. Okay, I made it to the next slide. So this is, I studied at Basel School of Design, visual communication, and this is a really basic exercise that everyone is doing in the first year, and it had really a big influence on me. So the thing is to have quite some restrictions. You can only use, like in this case, black paper stripes, and you have to come up with as many possibilities, as many designs as possible. And this approach we wanted to combine with data. So really going back to the single modules of data design, and then being able to define many more like individual diagram types. Usually what everyone knows and looks always a bit the same are these predefined chart types where you cannot map maybe more than 2 or 3 data dimensions, and they always look the same. So it's not really easy to find a new way with them. This is an atlas from Otto Neurath, who lived in Vienna in the 1930s, and he developed a method that is called pictorial statistics. We were always really inspired by it. And we analyzed it. So here we are in Vienna, actually in the museum where they keep the originals, and we are analyzing like the structure, how he was working, the colors and everything, because it had a big influence on our work, but also we wanted to understand more. So this was already before we started with the book project. Here is, yeah, this is, so the book project we started 2 years ago. I mean, the idea was already here before, but we were really busy with projects, and then there was a lockdown and we had like less project, or there was somewhere on hold. And so we took some time. We said it's actually a chance to go somewhere and to try to do our kind of PhD maybe in a short way, and going to the Swiss mountains to really focus, because in the studio it's actually not possible to work on like self-initiated projects like this so much. So here is Diane and me working in our mountain studio, like an apartment that we rented, and we were really, without looking at other projects, without looking at other dataviz books, that was actually our rule that we gave ourselves. We were just sketching and writing by hand, because for us it helps a lot to think. And Diane was working more on the data science side, like the data analysis, and me coming more from visual communication. I was trying to analyze like how I'm working, what I was teaching, how my process is actually, to understand that better. In the beginning, we didn't know if it would be like an article or a paper or even a book. So we just started. Yeah, when we were back at the studio, we took all the sketches, we rearranged them to find patterns, to think of what system we could come up to make data visualization like more fun, more accessible, and more visual. So we were changing that system, like I think maybe 3 times over and over again, because once maybe it did not work, once it was too complex. So, but in the end, I think we are happy with the system that we developed. So the modular information design system actually is divided in 5 parts. We have the data dimension. So this is just the table, the data, the rows in the table, all the values and variables. The diagrammatical dimensions are all the mathematical structures that you can come up with. You will see it in the next slide with more visual. And then the visual dimensions is also what Martin showed, like the color and the shapes and all of that. And then the structuring dimensions. And in the end, this system should help you to define your own diagram type and to make multidimensional visualizations. So what we came up with for the data, because we were thinking a lot like what data set we could use for the book, because the idea was to have one data set from the beginning to the end of the book. So all the visualizations should be based on one data set. And for us, it was really important that everyone can understand the data set. So it shouldn't be too big, not too complex. Everyone should be able to relate to. And what is really easy and everyone is really used to it is like a story of a family or like a family tree. So here, this picture is kind of random. It shows a family. It just shows that we have like 2 families, the family Brown and the family Wagner, and the surnames like Anna, Marie, James, Otto, Paul, and Elizabeth, and 2 like others that are not on the picture. And the thing is, how we were choosing the name was also based on statistics on the 19th and 20th century. So what was the most common names then was really like Otto, James, Marie, Anna, and for the last name, it was Brown and Wagner. So based on statistics about Europe. Here is like the first chapter of the book in yellow. So the structure of the book and the system has the same color code. Then in the system and the book, it's all overlapping the same color code. So this is the story or part of it from the family with already some highlights, the name, the year they were born, the year they were dying. So the text is really dense and it contains all the data that we need for the book. And in this yellow chapter, we are explaining all the steps from a text to like the final table you're using for your diagrams. So this is the first part of the table that you can extract from the text. It's like the family name, first name, place of birth, year of birth, hometown, and year of death. So super simple, everyone can understand it. This is the second part of the of the data. So this is actually everything that we used for the book. There's no more. This is all these 11 columns is everything. And there's some more parameters that you can take from the text. And then there's also others that we could like assign later, like or calculate later, like the age at the moment they were dying. And this is the second chapter of the book, all in blue. And it's actually really simple from the layout. We always have like an icon, like a symbol that represents this approach. And we have a really simple example on the left side, on the bottom left side, and the explanation text. Here on the left side, you can actually see the structure of the blue chapter. So the blue chapter, as I said, is like the mathematical components. So we went through, we analyzed all of them and we picked the ones that were really interesting and important for us for data visualization. So often you work with quantities like numbers, a value of something. The position is another category, and the relationship. So then the third chapter is the red one. So you always know where you are. It's the same structure than the blue one. You just have more elements in it. It's like 40, and here you can see a selection of 16. We defined an element set with 80 elements. So with these 80 elements, you can do this, actually all the diagrams and chart types that exist, but also if you understand the single component from the system, you can also create, or you should be able to create like more innovative, creative, new diagram types. Oh, I didn't say like, it's like about distinguishing like two categories, like men and women, or two families, like by the color or by the shape or the type of the line, the pattern. And then also we made some research about Otto Neurath and the isotypes, so the pictorial statistics, and we implemented these elements too. So for us, we worked a lot with it, but we didn't see it somewhere else, like in these kind of overviews, what elements you can use for data visualizations. And then comes the green part, and the green part is actually really important for how your diagram looks. So it's the structuring dimensions, and it makes a big impact if you align your data values in one line, like the pie chart, and not the pie chart, the bar chart you can see on the first little icon, or if you arrange them in a shape of a star or around the shape or free in space. And if you have too many of these data items, too many values, you might want to group them. So you can also align them in a line, in a grid, or free in space, for example. So we have 8 examples of 15 here. So actually, the whole book just should be an inspiration to maybe just change a small stuff in your chart or diagram type, or do a new one from scratch. So it can be used both ways. So the last chapter in the book is actually 26 examples of new diagram types. And our idea was to use all the 80 elements that we designed once at least. So they have overlapping moments, like we would always use the color for the same data dimension. So the data dimension of the family, like brown, the family brown is always blue and the family Wagner is red. So there are some things that are always repeating and there are things that are changing. And you can maybe see that on the next picture. Yeah. With every example, we have like the code on the right side. So yellow is the data dimension, like age, family, gender, hometown, generation. And on the and below we have the element that we're using to encode or to map the data. For example, here the age is the line length. In the book, we are explaining that system also in detail. So here you can see that we were mapping family, for example, as I said, with the color, gender with the saturation, generation with the grouping, and the age with the line length like before. And we were arranging our data values in this shape with an angle like kind of a star. And now, yeah, okay, now I'm gonna show you some examples of the book. I hope it's running, yeah. So there are like endless possibilities to work with data and just change the parameters. And for us, it's really important that you realize that what elements you change, what kind of impact does it have, and maybe not change everything at once, just one, and then you see what happens. You make a series and you choose what is the best visualization for your data. So because we don't say, don't make this, don't use that, we just say like, try, okay? We made a Kickstarter campaign, and of course for our over 700 supporters, we gave them some dataviz postcards about our Kickstarter campaign. So yeah, we were really overwhelmed that we sent so many books to the US, also to Japan, Canada, Australia, many to Europe. So this was really an amazing experience for us. This is the book flip through. So you can see again what I was showing before in single pieces. And of course, you can still buy the book in German and in English everywhere where you can find books, but only like in our online shop, you can find the poster that is like a summary of all the 80 elements. Yeah, that's it.
Perfect. Nicole, we're good. 20 minutes. Super.
Very good.
Okay, thank you. So questions, as I see, some are coming. There could be more because there are over 220 people just live watching. So just ask us questions and upvote the others. And now, Christian, we are very curious to see your visual systems. Nicole, mute.
Okay. So I will talk about data anatomy and aesthetics in my talk for these 20 minutes. My name is Schneider. I live and work in Bern and Vienna. What do I do? I'm really into looking how data visualization can make complex data more accessible with a focus on complex data. I like to search for patterns in data and reveal those patterns. And I'm particularly looking for finding the hidden beauty in data, because I'm convinced that there is beauty inherent in data. I have a computer science background. I studied computer science. I worked in architecture research for 5 years at the ETH Zurich before I changed to the statistics office of Zurich, where I worked for also about 5 years. And since some years, I'm working independently. Here you have my contact details, website, email. So what will I talk about today? I will just give an insight how I usually work, how I deal with data. I will just kind of show my approach when I start to work with data sets and visualize them. There's a bit of philosophy coming in here, and I try to kind of pinpoint and ground what I say in project examples. These examples are mostly projects I was working on, but some of them which I show are projects from other people, which just kind of nicely illustrate what I mean. So I'm working kind of in the realm of generative design and data visualization. If the black circle would be generative design, I see the orange circle as data visualization. So I actually see data visualization as a part of generative design. Why that? Because both for me is painting by numbers. Especially for me, as I'm coming from a computer science background and I'm programming a lot, it's just both is painting by numbers. So you always have numbers which you somehow transform into geometry. There are systems like we've seen before in the two previous presentations. The numbers, they come from data, numerical data or other data, and these data, they stem from the real world, or you actually generate them through a simulation or through a generative design system or something like that. So we have some similarities here. And so my goal is to kind of take this circle of data visualization, how it is today or how it was 10 years ago maybe, and bring it more into the realm of generative design with the possibilities of generative design. Yeah. So I always work with code. I don't have any Adobe program installed on my computer. That's the only thing I do. I work with code for data manipulation. I work with code for visualization. I work with code all the time. And I think the fact that I'm working with code influences a lot what comes out of the work I'm doing. So when we speak of data, we often imagine something like this. We have like it's something in a tabular shape, a lot of numbers, somewhat abstract. Some people are afraid and walk away. Some people think it's very, very boring, but I think it's actually very interesting. If you look at data as a mountain, we can ski kind of down this mountain in different ways. We can ski down this mountain in a very efficient and strategic and accurate way with really professional tools, for example. We are well trained, we have techniques, and we have a goal with a specific outcome. That is one way we can deal with data. The other way is kind of a free ride approach, where we just start to play with data and look what comes from the data. and where it brings us. So when I work with the data sets, I always have the assumption that there must be some kind of hidden aesthetic in this data. Why is that? Because data is always kind of a mirror of the real world. And when you go to the real world, if you go to nature, if you have geographical data, if you have sociological data which are based on people and their interactions, if you have maybe urban data or traffic data or weather data, it's always based on our real world, the real universe. And oftentimes what you find is kind of an inherent beauty in that. So, you know, if you take a plant, it's usually kind of beautiful in the form, but it is a masterpiece of engineering in a way from nature. At the same time, it is highly optimized. So that's kind of the assumption, that because data is a mirror of the real world, there must be kind of some aesthetics hidden in that. And I would like to illustrate that on this example here. There's an older work I've been doing some years ago. I call it Silk, and it has a certain aesthetic to it. It's computer generated, but how was this generated actually? So let's look at this, how it was generated. What we have here is a simulation of a rope kind of growing in zero gravity, and it kind of just moves in space here. But it's a physical simulation. So we have physics. And so if my assumption is right, if we use physics here, there must be some kind of hidden aesthetics in that. But this alone, I don't really like that much from an aesthetic point of view. And what if we just don't draw this rope directly, but we draw the path of the single elements of the rope? Then we get something like this. And we see kind of the sum of paths of each element of the rope, kind of creating the shape in the end. So you get an idea. You get an idea from the darkness or the lightness of the colors. You get an idea what was happening with in terms of speed, where the rope was. Where was it more? Where was it less? Where did it move faster? Where did it move slower? I'm always interested in raw data. So if I work with a client and he gives me data sets, oftentimes it's kind of aggregated data in a certain way. Then I usually ask, well, do we have the raw data of this data? Because in the raw data, there as well, my assumption is that it's kind of closer to life if you take the raw data. And when it's kind of closer to life, to the reality, maybe it has some different stories to tell you, which you are not looking out for at the moment, but which are really interesting. So I think if you can work with raw data, it's kind of like with food. If you have like fresh kind of food, you can also make fresh, nice meals. As opposed to processed data, where I think if you process data too much, you lose something. On the one hand, you definitely you lose information always if you process data too much, and you kind of, with the information that you lose, you might also lose some kind of interesting aspects of the data which you weren't even looking for, but which could be revealed somehow when you work with the data. So I want to illustrate kind of the beauty of raw data with this example, the racial dot map. It's quite an old work, it's not from me, but it illustrates nicely kind of an approach I have. So what we see here is we have a map of dots. Every dot represents a person. The color of the dot represents the ethnicity of the person, and the location of the dot represents the address where the person lives. So we have a really, really simple visualization. We just have dots here. The data set is also quite simple. We have a person living at a certain location and having a certain ethnicity. It's quite a simple data set. But when we visualize the raw data here, suddenly we get information which is inherent in the data, but not explicitly there. For example, we clearly see, this, you see the geographic boundaries of the United States, for example. You see where cities are. You see where rural areas are. You see where the white people live, so the blue dots. You see where the black people live, the green dots. But you even see where mountains are and where flatlands are, just from drawing dots. And I think that's very, very interesting. And such effects, they might be there in any kind of data set, even in more abstract data sets. And that you suddenly, if you visualize the raw data, that you suddenly something appears which you weren't looking for, or which is not explicitly in a row or a column or something like that in the data. And then, of course, the raw data invites you to kind of to look around and to explore. And somebody did that. Somebody wrote the blog, and this person then discovered that in areas where there are many rural areas where there are many white people living, which are not densely populated, you always have kind of an area which is very densely populated where there are mainly black people living. And you see this pattern again and again all over the United States. And this person was asking herself, well, why is that? And that's my question to the audience. Why is that? What's happening here? Why do we have a densely populated area with a lot of black people in an area which is not densely populated, mostly of white people? I mean, maybe you can write it into the chat, and maybe Darian can tell some assumptions.
Okay, I'm nothing there so far.
Okay.
I give it 20 seconds, otherwise you answer it.
Yeah, otherwise they'll. So what could that be?
Okay. There's one. I tell one. There's one. One came.
There's one.
Prisons.
Exactly. That's it. And then you can ask yourself, okay, why is it that so many black people are in prisons? And then you have this sociological question and so on. We don't go into the details of that, but these are the kind of patterns that suddenly arise when you work with raw data. This work here is a work I've been doing at the University Clinic of Regensburg in Germany, in Bavaria. I worked with a group of scientists there, psychiatrists and psychologists. They were doing research on tinnitus, this kind of annoying beeping noise that you sometimes hear, which is produced by the brain. And they had a data set of 5,000 patients, tinnitus patients, and they had information of these patients at a given point in time. How strong was their tinnitus? How loud was it? Which kind of tone frequency did it have? How was their mood when they had this tone frequency tinnitus, and so on. So it was a very high dimensional data set of 5,000 patients approximately. And they just told me, well, just do whatever you want with this data, and we'll look at it at the end of the week. So we decided to do like this kind of science fiction-y multi-dimensional visualization with these cubes, three-dimensional cubes, where you always had three axes, X, Y, and Z axis, where we mapped different kind of variables of the data set. So you get kind of these different shapes of the data, depending on how you look at the data. And here in the left side, with kind of a two-dimensional view of the data, where you could select certain data points. and what you select is also visible in the other visualizations. Yeah, and so then at the end of the week, I showed this to the scientists, and these scientists, they really knew their data set very well. They wrote papers based on the data set. They were really adept. They had adept statistical skills. So they really knew the data sets really well. But when they looked at the visualizations, they were like, oh, okay, what's this patterns? Why do we have these dots here? And they started to look at their data set from a different angle. And sometimes the patterns that they would see, which they would observe, they would be very obvious patterns because the data, or obvious correlations that you would see, but sometimes it was kind of a surprise to them. And then they decided to kind of look at this group of patients, for example, more precisely. And then they were like, because they're scientists, they were like, oh, okay, let's write a paper about this. Something like that. So this is an example. If you kind of just play with the raw data and it's just try to visualize it in different ways, I think already this can kind of inspire people to do things or to explore the data set further. Then next project I would like to talk about is this here. It's called Urban Data Patterns. I made a series of visualizations together with the graphic design and communication bureau in Bern called Hahn and Zimmermann. We made this project, Urban Data Patterns, and made several visualizations based on different urban data sets. And this is one of them. What you see here are the trees in the city of Bern. One tree is one line. The length of the tree is the age of the tree. The color of the tree is the type of tree. So is it kind of a pine tree, or is it a tree with leaves or something like that? Is it the fruit tree? And then the location of the line is the geographic location in the city. So this could be a street or a park or kind of a square or something like that in the city, like a geographic location. And so what you see, you get these different shapes, which are kind of characteristic for a certain geographical location. So what you get, for example, here you get like many old trees and very few young trees, or here you get just a few old trees and many young trees. So this gives kind of a characteristic shape of each geographic location. There's a website also with that, urban-patterns.ch. Then what I would like to show here is that, well, sometimes you don't really need to, well, what I was experimenting here is kind of trying to not visualize the data, which is in the data set. Well, the data set here was the building footprints of Zurich. And I was thinking of how can I kind of show this data without explicitly drawing the data in the data set, because usually we take the data and we're transforming in some visual variables like we've seen before in the book presentation. But what if we're not allowed to actually transform the data into visual variables? So what I did instead is kind of simulate people in the city, how they walk around. So it was just an agent system, and they weren't allowed to walk into buildings. So when they would kind of walk into a building, they would just turn around and walk away, and you would just trace their path. And that's what you then get. You get an idea of the city of Zurich, you get an idea of the streets, for example. But I didn't visualize the data set itself, which is underlying, which is the building footprints, and that's the result. here a visualization, animation of that process. And here a close-up. And that's it. Thank you.
Thank you. Thank you, Christian. Thank you, Nicole. Thank you, Martin. Now we are kind of done with the official part with our talks. We are now going into 15 minutes of questions before we start going to Kabar in Basel to have a drink, because it's a nice evening, so we should use that. So there have been 19 questions. We won't be able to answer them all, but we will take the most popular ones. And I'm just really kind of taking the ones which are mostly upvoted, and then we walk down to the ones which have less votes. So the question to Nicole, it's coming from Natalia. And Natalia says, for Nicole, thank you for your interesting speech. The diagrams are just great. Do you invent some new types of charts which became useful for someone?
Yeah, hi. Yeah, I think we have developed some diagram types in earlier projects before we did the book, where we realized that this is actually a new diagram type, and it was really successfully applied. So I think that also motivated us to research more on how we build that one, how we could build other ones. So yeah, I think it's like very popular, and everyone should start doing it. I mean, you can make small changes or bigger changes. So, but we didn't. One, I think we gave a name, but the others we didn't name it yet.
Which one is it?
Yeah, we call it the scissors diagram that we used for the visualizations of prices and earnings in many cities in the world.
I will try not to answer questions in this case. I'm really, it's difficult for me. Nice, thank you. So if Christian or Martin, if you also want to add something at some point, just feel free. We have an open conversation. Okay, otherwise, Martin, there is a question from Roman Daimel who says, how do you explain to non-designers what the advantages of a visual systems are or is?
Yeah, there are a couple of advantages. I mean, one is as well consistency. I mean, at least visual consistency. Another one is if you don't have a system and you need to invent always the wheel from scratch when you start a new deliverable, then you're wasting a lot of time, and probably it's going to look all very different. And then if you have like logic rules that everybody can understand as well, I mean, there are like two difficulties or problems already lying in that answer. So on one hand, you have to have a system which makes sense, and then you have to as well, you have to communicate the system in a way that everybody understands it. But if you are able to do this, then you have a tool as well to have bigger teams working on projects, which as well allows you to do bigger projects. And it allows you as well to include different people with different perspectives. So you get a higher diversity, and also you can get, I mean, in diversity in any kind of sense you could imagine, no, which is important, and changes as well from project to project and the function each project has. Yeah, and then basically what we do, I mean, just like I mean, just like in hands-on advice, what we do is when we present to our clients, because I understand the question and the problem as well, because it takes you more time to develop first a system and not just a deliverable and then later a system. What we do is we explain the system as simple as we can, and then we show the options or the things that you could easily do with it. So we show them as well that once you have these set of rules, then you can do very quickly lots of other stuff they never have thought about.
And I think this question also is interesting to hear the perspective from Christian and Nicole. So what is the advantage of having a system, or how do you explain that to a client?
Yeah, exactly what I thought. The advantage is also that if you have a system, you can program it, and you can automate kind of the generation of outcome, like you showed in your slides, Martin, as well. You programmed this system where you could kind of design posters and all that, which gives you new possibilities simply.
Also, sorry, but I want to add something to what Christian was saying, is because there's also a tendency now with bigger design studios that they're coding tools. And if you compare a coded tool that the customers can use to generate their own graphics, then this is a huge advantage in comparison to design manuals, because design manuals, like these big books, they always have been misinterpreted or misunderstood. And this cannot happen if you generated, or if you have a tool, if you coded a tool that has all the rules implemented.
So probably the return of investment is happening a little bit later, because in the beginning there is a bigger investment, but kind of over time it gets more and more efficient and cost effective.
Absolutely, yeah, absolutely.
Yeah, and I would say in data visualization, it's really important because you anyway need to come up with this system. You need to define like how you map, like for example, quantity, or how you distinguish two categories. And if you're aware of the system, you can make small changes and you have a lot of variations. Or if you program it, you can build a lot of different visualizations in like one go. So with different data. So it's always data based, but you have to be aware of what to change and finding like your own visual grammar for data visualization. So because you can use maybe like we did 2 colors for the 2 families, but you could also use 2 patterns or 2 different kinds of lines. So you can really play with that. And once you set this grammar, you can build a lot of diagrams for all the data that you have. So it actually doesn't work without the system, I think.
So I see the next book coming up. It's called Data Branding.
Yeah, I think there are like many overlapping parts with like generative design, where you define the design rules based on data, but you cannot read it anymore. But also like for visual systems, for branding, you could use data to define the shapes, and then you also cannot read it anymore. So I think there's like a big overlapping part in all the 3 approaches.
I have a question for Nicole and Christian, actually, and Diane, to the 3 of you. Yes, so the moderator can answer as well. So my question is that, I mean, a system in a way as well, when you, is like a visual language, because you're establishing something that has a logic and that wants to be read. So at the end, you want to communicate something as well through the work that you do, I guess. So the question that I have, which may be a little bit vague, is you don't want people to read manuals before they are able to read your work. So what kind of relation do you see to the systems that you develop and the language that everybody knows already? And I'm not just talking about verbal language.
Mm-hmm. So what I understand is actually that you say, okay, if you invent a new diagram type and people are used to bar charts and pie charts, will they be able to read that, right?
Yeah.
And the good part is I'm just summarizing because there is the same questions coming up. So there is a person I just want to highlight who says, did you do anything actually from the other side? It's a different question to that. The same. Did you do anything to validate the MID system with different users? Does SuperDot or kind of everyone face any changes? How low graphical literacy in audiences? So kind of how do people read the graphs? So that's kind of a very common question coming also into that direction.
Yeah, I think with like the regular chart types, we always assume that everyone can understand them, everyone can read them. But I think it's not so much a question of the chart type, but also how you make the legend, how you make it accessible, how you explain it. And yeah, for me, I'm convinced that you get more attention when you do another kind of diagram type that you have not seen before, like super many times. And of course, you have to make sure that the data is correct still, and that it's readable and you can test it. I mean, we do it like with, we make many variations, and you have to test it yourself, but with others, like if it's understandable, but you definitely get more attention. So yeah, but of course it would be interesting to make a study, but we didn't do that yet.
I think also a point is that how successful a chart is or something like that is how engaging it is, you know. How interesting it looks to the viewer, how, you know, oh wow, what is this, how interesting is it? Or that's also an important factor in kind of getting the person hooked and wanting to actually look and understand the chart. Yeah, so for example, if you can add interaction or something like that, you can add a different layer and it gets interesting and the person can engage with the chart.
Yeah, I would also add, okay, I'm answering now. So I would just also add that kind of the logic of readability is also the same logic for user interfaces and software. So kind of how do people understand what they have to do? And it's always a good approach for us, at least, to deliver the necessary information for understanding at the right point. So not everything at once, but you say, okay, in this chart, we have been using dots to represent quantity. One dot is, and then kind of step by step, they can kind of understand how that multidimensional system works. So we always say kind of that we don't aim to produce charts which are understandable in 5 seconds, because then we have to always take the ones people already know.
But also these, the standards can be done well or really poorly. I mean, it's like small details that make a big difference.
Question for Christian. We didn't have Christian. Christian, when are the moments you wish you have some Adobe applications installed?
When I teach.
Okay. Okay, that was fast.
No, I don't really get into that situation, to be honest. I do this many years now, and it's just, well, I don't use an Adobe application. I use a graphic designer who has an Adobe application installed on his computer usually. So I usually, often for clients, I work in collaboration with other people, because I'm more kind of from this computer science side, and there are certain things which I cannot do from the design perspective, and therefore I need other people, and they usually have Adobe applications.
Mm-hmm. Mm-hmm. Okay, cool. So there's time for one more last question. I will just, does anybody want to have a question, or just I take the next one in line? Somebody for a question? No. Okay, good. So the next question, it's a little bit going in the direction we have been already discussing. It's going to Nicole. Nicole, working with your visual system, how do you control data accuracy?
Yeah, I mean, for us, it's not a question if you do like a new innovative kind of data diagram or if you do like a standard chart. So the data always has to be accurate. For us, this is two separate things. And yeah, we don't at the moment. I mean, we explain like in the book, like from step by step, like how to get from the data to the visualization. So you can use that for any chart or any diagram that you are doing. And yeah, the thing is, we don't say for this kind of data, this diagram or this chart type is correct. That's our approach. And that is very different from other database books. And if you want that, there's so many great database books out there that you can look that up. So that's why we didn't include it in ours.
Super, thanks. Okay, just I see the next question is super small and it's going direction Christian. What code, as kind of, you're coding in what? Is there a fast answer?
It's probably asking what language or what
exactly.
Different, and it changes over the years. For client projects, I use a lot of D3 with to create visualizations, but I use front-end frameworks like Vue. I use, but you know, something like React or Angular would work well for web projects. Then I use Python for data related tasks. P5 a lot for playing around. I did a lot of processing years ago. I used open frameworks. Many different things. I worked in 3D modelers and programmed stuff in there, like in Rhino, depending on what you do.
Super. Yeah. So the whole world. Yeah, I see that. Okay, so thanks a lot. Speakers, you stay. I will now turn off the live feed. For everyone who has been joining for over 1 hour, thanks a lot that you have been part of this session. There will be more this year, so I hope you liked it and see you soon.